All right, this is going to be the last couple of examples from the quadratic function graphing section where we learned about the standard form ax squared plus bx plus c. We learned about the vertex being either the highest or lowest point, which sometimes we call a minimum or a maximum. And we learned how to graph our quadratics. So I'm going to do the ones that we skipped over in class. The first one was this example right here. Says find the maximum y value on the graph of f of x equals negative 2x squared plus x minus 10. So when you're dealing with something like this, the word maximum is what's telling us we need to find our vertex, okay? So maximum or minimum on a quadratic means vertex. And then they only want the y value, which in our vertex, we usually have, we call those h and k, just to distinguish them from other x's and y's. So we're looking for that k value. So what we learned is that if we list out our A, B, and C, so this is -2 for A, B is a +1, and C is a -10. The formula to find H, because we have to find that to be able to find K, is H equals -B over 2A. So that would be -1, since we have a 1 here, over 2 times -2. So that's going to be negative over a negative overall. So that's going to end up being a +1/4. Now we're going to plug that into our function. So we have f of 1/4. So this will give us our k value, the one they were looking for. And that's going to be -2 times 1/4 squared plus 1/4 minus 10. Okay, so 1/4 squared, you square top and bottom. So that's going to be -2 times 1 over 16 plus the 1/4 minus 10. Reducing this, we have that would be a -1 and an 8. So that's going to be just -1/8. I'm going to go ahead and get a common denominator for these other two. If you think about that being 1/4 and 10 over 1, we would times the 1/4 by 2 over 2 to make it have 8 as a denominator. And then we would times this one by 8 over 8 to make that a 8 in its denominator. So that's going to be -80 over 8. So they all now have a common denominator, or you can use your calculator. And this would be 1/8 minus 88. So that's going to be what? -79/8. Let me double check myself. Yes. So that's the y value there. Okay. All right, now we had one other graphing problem to do and then an application problem. So this is the last graphing problem from our notes. So notice the A here is a -5. The B is missing, so that means it's 0, and the C is a 1. So remember, BX has to have the X. This one's going to open down because we have a negative for our A value, and that means it's going to look like this visually. The graph is wider, narrower, or the same. Now notice your A is a 5. Anytime your A is bigger than 1, you get a very quick growth. So that makes your parabola skinnier or narrower than the original just 1x squared. Does it have a minimum or a maximum? Well, if it's opening down, it's going to have a max. That's why I like to draw that picture. Okay, to find our axis of symmetry in our vertex, we have to use our formula for the vertex. So H equals -B, which is 0, over 2 times A. That's just going to be 0 over -10 or 0. So my axis of symmetry is at x equals 0 because it's always a vertical line through that H. And then the vertex number uses that as its first coordinate. Okay. And then we're looking at finding the k. So we're plugging 0 into our function. So f of 0, we're going to plug it in for all of our x's. So -5 times 0 squared plus 1. That would be 0 times -5 is 0, so it's just going to be a 1. So this vertex is actually a y-intercept. It is the ordered pair 0, 1. So I'm going to go ahead and put that on my graph and look the little v next to it. The x-intercepts on this one are not going to be pretty. So when we set, remember, to find x-intercepts, you set y equal to 0. Okay, so my function was f of x equals -5x squared plus 1. Well, unfortunately, f of x is the y, so we put that in for 0, and this is not one that we can factor. But we can try and solve it using something we learned in one of our previous sections in class today. I'm going to add that 5x squared over to the other side. Since I don't have a bx term, if I divide over that 5, I can use the property we learned that said if I have something squared equal to a number, I can take a square root of both sides. So if you do that, though, this is where you have to remember that you have to put the plus or minus. So that's just like what we were doing in class today. Now, if you write that, you get a negative square root of 1 over 5 comma 0 and a positive square root of 1 over 5 comma 0. Now we could rationalize those denominators and get the radical out of it, but essentially when we're graphing something like this, I like to look at what it is roughly as a decimal, just because that helps me graphically. So we have 1 divided by 5 is underneath the radical, so that's 0.2. We'll take the square root of that. So this is about a negative 0.45 roughly and a positive 0.45. That's just a rough estimate so that when we're graphing it, we know where to put it. Now the y-intercept is the vertex, because when you plug in 0 for x, you're going to get the 1 again. So we've already done that. So we're actually only going to get 3 points. So just a little less than halfway on the negative 0.45 and the positive 0.45 on the x-axis. So notice this is a really skinny little parabola. Okay, really narrow. All right, so that ends up with the graphing. Now this last question, this application one, it says, suppose that a baseball is thrown upward with an initial velocity of 66 feet per second, which is 45 miles per hour. It is released 8 feet above the ground. Its height, h, after t seconds is given by this formula. So they gave us a quadratic. After how many seconds? So we're looking for t. Does the baseball reach its maximum height? That's the key word. And we're estimating this height. It's going to come out to a nasty decimal, so we're going to actually round it to a nearest whole number or integer. But maximum height means vertex. So we're going to do the finding the x, or the t, essentially. So t equals negative b over 2a. My b is 66. That'd be negative 66 over 2 times negative 16. So that's negative 66 over negative 32. So we divide that. It's negative over negative, so it's going to be positive. And then they said round to the nearest whole number or integer, which means 0.0 will not bump that up to a 3. So that's going to be roughly 2 seconds. So it's going to take 2 seconds for that baseball that's being thrown up to reach its maximum height. And then they said estimate this height. So we want to plug it in and find the height. So we're going to plug in 2 seconds for our t. So essentially these application problems, if they say find a max or find a min, and it's a quadratic, you're just doing your formula for the vertex, okay? So this would be, let's see, that's negative 64 plus, I don't know what 66 times 2 is. 132 plus 8. So if we add those, let's see, I'd subtract the 64 from the 132 and then add 8. That's going to be 76 feet. Okay. So the baseball reaches its maximum height after approximately blank seconds, so roughly 2 seconds, and it was being thrown upward. The estimated max height in the air is 76 feet. Okay, so that ends the notes from today. So I'm going to be doing a separate video, remember, like we talked about, for the quadratic formula.